So the video is from Benjamin Haibe-Kains from Medical Biophysics at University of Toronto on artificial intelligence.
Hi, I am Benjamin Haibe-Kains. I'm a senior scientist at the Princess Margaret Cancer Center and an associate professor in the medical biophysics department of the University of Toronto. And I'm a recently elected member of the College of New Scholars of the Royal Society of Canada. So today I would like to discuss a topic very close to my heart, which is how to make your research more transparent and reproducible in the field of machine learning and artificial intelligence. Those are my disclosures. So first of all, reproducibility is really fundamental to the scientific progress. As you can see in that cartoon from Sidney Harris, when you prove a theorem or if you publish the results of an analysis, it's very important to document every steps along the way. And the reason is that it's very hard to build upon a miracle. And so in the field of computational research, where you basically just have to run the same computer code on the same data to obtain the same results, full reproducibility is definitely achievable. So it sounds very easy, but is it? So if I share the data with you, and if I share the details about my code and the software environment, then it should be fairly easy to reproduce a full study. But the reality is very different. There are many things that can go wrong, many details that are often overlooked and not documented in papers that really makes it very hard to reproduce any given study. So you need to really put a lot of efforts to make your research more reproducible. So I'll give you here the key elements of a typical machine learning and artificial intelligence pipeline. So usually we start with raw data that you use for discovery. So you do the quality control and processing, you organize those data so that you can run your analysis. And that's usually, if you want to build a predictive model, that's where you train your model. So you try to understand the relationship between the input features and what you're trying to predict. And then you get this final predictive model that you have to validate. So what you do is you collect completely new data for the validation of the model. And you go through the same quality control and pre-processing. And then you get those data you can use for predictions. You use the final model to generate those predictions, and then you see whether the predictive value of the model was high or not. And so along the way, you've generated quite a few elements that are of interest for the scientific community. First of all, the data, the raw and the processed data. You've also generated computer code at three different steps: for the quality control and pre-processing, for the training of the model, for applying, generating the prediction using the final model. You also have code for the model itself, which is basically, in the case of a neural networks, the model architecture, and all the weights that connects the neurons, for instance. And something that's often overlooked in the community is how we have to document, is the documentation of the software environment. What kind of operating system, what kind of software libraries have you used to generate all those results? So if you share all those elements, then you really make your study not only fully reproducible, but very easy for others to scrutinize and leverage and reuse in other contexts. So when you share the raw data and the code and the process data and the models and the software environment, then it makes it really easy for others to leverage your study and move the field forward. However, if you don't share those outputs, if you don't share the data, if you don't share the computer code, if you don't share the model, if you don't share the software environment, then there is virtually nothing that a scientist or an interested readers can do to kind of move the field forward, maybe reusing that model and validate that model further. It's not possible because you didn't share those elements. And so even so you may have published in a scientific journal, I would argue that this is not a scientific publication. It's a mere advertisement for potentially cool but closed technology. And this is especially true in the field of computational biology, where the full software environment, code and data are the scholarship, and it's not so much the results. So what have we learned in the last decade of focusing on this topic? So first of all, making your research fully reproducible takes a lot of time and expertise, and therefore you should budget those costs for your projects. if you really want this to be successful, if you really want to make your research more transparent and reproducible, you have to put it at the center of your lab's modus operandi and mission. So each time you onboard new people in your team, you really have to discuss that during the interview, set the expectations for new recruits. And frankly, you have to make it mandatory. There are a few exceptions where data and computer code cannot be shared, but in the vast majority of cases, it is possible to share all the elements of a study. But you have to resist the pressure. We're all in a hurry to publish. Competition might be tough. You may be working on a very hot topic. But I can tell you that making your research transparent and reproducible is greatly appreciated by editors and reviewers. They see the potential higher impact and potential higher citation rate for your paper. And it's an investment. When reviewers are going to go back to you about the new analyses that are required for your study to be published, you'll be very happy then that everything is documented and easy to reproduce. Something that is also I have also observed along the years that telling my lab members that the data encode and software environment will be shared is a strong motivation to really improve the quality of the research itself. And if you build virtual machines, it also makes it much easier to collaborate because it's much easier for other people to run the code and help you debug and generate interesting results. And that is true also when you iteratively update your analysis code. And all in all, sharing research, all those research outputs really increases the impact of your study. And what I've witnessed too is that it provides also a lot of opportunities for new collaborations. People will go to you because because they're interested in your methods and data, and they will ask for your advice. And if you made your research so easy to reproduce that they can do it on their own, and that's a victory on its own. Another point is that open science and research reproducibility do not prevent commercialization. So you can have an initial scientific discovery that is completely open, and you can still build a commercial product. You can still generate revenues based on that. So it's a misconception that open science do prevent any kind of commercialization. Something very important to note, though, is that it's not because your research is transparent and reproducible that the research itself is error-free. There might still be errors in your analysis, but because it is transparent, because it is easy to reproduce, then those errors can be identified and corrected, and the field can move forward. If you don't share your data, if you don't share your computer code, it's virtually impossible for other scientists to actually find that errors, and it takes then a long time for the field to self-correct. So in conclusion, investing in research reproducibility and transparency is really investing in impact. It's really increasing the impact of your research. And if you use the right technology, if you spend the time and expertise required to document all the steps, then research reproducibility is totally achievable, especially in the field of computational research. So if you're interested in the topic, we've published a paper in Nature in 2020 describing all the technologies and the platforms that you can use to make your artificial intelligence and machine learning research more transparent and reproducible. Thank you for your attention.